This is Dean Phillips with Longevity Industries bringing you the Destiny of Manufacturing podcast, brought to you today by the Precision Metal Forming Association and the PMA's Educational Foundation. We're glad to have them as a sponsor, and we appreciate their support for the show. I have an incredible opportunity today. I have an opportunity to interview Dr. Lonnie Love from Oak Ridge National Labs. He is a corporate fellow over there. How are you doing, Lonnie?
I'm doing great.
It's great to have you here. Dr. Lonnie Love has been a great supporter with the Society of Manufacturing Engineers, formerly known as, currently SME, and also serves on the board for the member council and has always done a great job, and we really appreciate all his hard work for the industry of manufacturing as a whole. Thank you, sir, for all your hard work.
It's a real honor and a real pleasure.
Thank you. Tell me a little bit about your background, how you got involved in manufacturing as a whole, and how you came to be at Oak Ridge.
Sure. Well, my background is in robotics. When I was in graduate school in the late 80s, early 90s, I just fell in love with manufacturing and robotics. And as I was finishing up my Ph.D. and trying to figure out, what I wanted to do between teaching at a university or working in industry or working in a national lab, I looked at all three, interviewed at all three, and really kind of felt like I could have the biggest impact and the broadest impact by working at Oak Ridge National Lab. So in 1995, I came here and fell in love with the place. It's a really fantastic history in terms of manufacturing. A lot of people aren't familiar or aren't aware of Oak Ridge's role in terms of advanced manufacturing, and really our real motto is transforming fundamental scientific discovery to manufacturing. The whole Manhattan Project, where we were founded, was based on that, of taking basic scientific discovery in terms of enriching uranium and scaling it up to full scale at a very rapid rate to try to develop the materials we needed to end World War II. And since then, Oak Ridge has got some just unbelievable tools that are really, to me, critical for the future of manufacturing. So I really feel like, I'm in the right place at the right time with the right group of people. It's a real exciting time.
Yes. And Oak Ridge has a long history besides the Manhattan Project. There's a lot of things that probably people don't know about it. And it houses a supercomputer there, or at least I don't know what level that computer's at now, but I know that.
Yeah, we're back at number one. And it's a competition. It's a new Cold War, a new race between us and China in terms of capabilities. But you're absolutely right. Right now we have the world's fastest computer. And in terms of manufacturing, there's a whole program looking at high performance computing for manufacturing. So you're exactly right.
Yeah, and Oak Ridge has such a leadership role in technology as far as additive, and has always blown me away as people. You don't realize all the things that the lab gets involved with, from doing things like obviously robotics, doing things in forming and fabricating, doing a lot of additive between the robotics aspect of I guess replacement limbs and some of the things that you guys have really worked on to explore that science too. But it is phenomenal.
Well, and I think the thing that's our greatest strength is that we're very open. What a lot of people don't realize is that we embrace industry coming in and working side by side with us. In the manufacturing demonstration facility that I work in right now, there's probably on the order of 10 different companies that have co-located with us and taking advantage of all of the capabilities. Because like I said, when you start looking at Oak Ridge, our key strengths are modeling and simulation. So using high performance computing to model and simulate processes, And then when you start looking at characterization, we have some of the best characterization capabilities, from best microscopes down to some really unique neutron sources. So in most manufacturing processes, you're battling stresses, and we have two neutron sources. One's a high flux isotope reactor that you can use to do 3D tomography of residual stress, and then we have a spallation neutron source that kind of does the same thing. So you have the ability to synthesize new materials, process materials, model and simulate it, and then validate it all within one laboratory. It's just absolutely phenomenal. And like I said, the real key, though, is industry engagement. We have about 1,000 companies a year that come into our facility, and we really kind of embrace looking for ways that we can leverage all of these tools to help companies become more productive and more competitive.
Right. And you guys definitely are at the forefront of all of those things. Tell me a little bit about when you got involved into manufacturing, how much it's changed from that point to now, and where you think it's going to go over the next 5 years.
Oh, it's like it's on a rapid exponential growth curve, I believe. I mean, I know that when I came into to manufacturing, it was back in the 80s, and we were just starting to see the first, adding computer control to the CNCs. We were starting to get into robotic systems that could be programmed to do pretty complex tasks. And then you also had in the late 80s and early 90s birth of additive manufacturing, of 3D printing, but it was still very, very immature. And over the past 20 years, 25 years, we're starting to see the costs starting to plummet, the performance of computing going way up, the cost of the sensors going way down. And now as we get into the wireless, and you get into cloud computing, and I think we're going to see another huge transformation in terms of manufacturing, where we already are seeing machines talking to machines, machines talking to the cloud. Where we're going, that's what excites me the most, because I have no idea. And I just know that all of the fundamental tools that are coming together, from AI and deep learning to data analytics to new manufacturing processes such as additive. There's some real disruptions going on in additive, hybrid machines, typical conventional CNCs that have the capability to both subtract as well as add materials. I think it's just really exciting, and these new tools are going to enable more companies to get into manufacturing. One of the things I'm really a big believer in is that these technologies will enable us to go back to kind of the more distributed manufacturing, where every town can have the capability to make stuff, and much more flexible. You've got a factory that can be reconfigured and reprogrammed at the drop of a hat, depending upon demand. So I think it's a real exciting time, and hard to predict where it's going to go.
Right. It is. And I know that you serve on the advisory committee for smart manufacturing with SME. As far as some of the areas that those are kind of, I guess the best way to talk about it's spidering out in different directions, and it's kind of advancing in all of these different opportunities. Where do you think have some of the best opportunities for growth as far as that goes?
Oh, that's a great question. I think that there's a lot of opportunities, and this is going to be hard. As we get into manufacturing and trying to create this digital thread where you can track absolutely everything from the design, the supply chain, the manufacturing process, the post-processing, and the delivery of the final product. and even having sensors to provide feedback. This is another thing that's going to be extremely exciting, this ability to embed sensors in your system and communicate to the cloud that can come back to the factory and provide you feedback on performance that you can then iterate on your design rapidly. All of this is, to me, really interesting and really exciting, but it's going to be really challenging because now we're going to be dealing with a lot of data. You're going to be dealing with cybersecurity issues. How do you secure that data? And you're going to need you're going to need engineers that are very knowledgeable in terms of data analytics, in terms of artificial intelligence. I think artificial intelligence has been around for a long time, but I think it's finally kind of really, the capabilities are getting to the point where it's going to have a bigger and bigger impact. The challenge that we're going to have in terms of manufacturing is finding the workforce that actually understands it. We're going to be competing with the Ubers, with the Googles, with the Netflix. These are talented individuals that are in great demand. So that's going to be something that'll be really challenging. But I think it's something that SME could really embrace. You don't need to have a Ph.D. in advanced mathematics. We could be doing training such that we could provide we could upgrade the workforce and teach them how to use these tools to be more effective and provide a great service to the manufacturing supply chain, to all of the people in the United States that are really trying to stay on the edge and to be more competitive. I think that's one of the areas that I think is going to be really challenging, but really exciting.
Right. I think it's really difficult now to really take in the scope of how difficult it is to stay up and compete. I think the timeline that there used to be for manufacturing, I know being involved with the Precision Metal Forming Association and some of the reports of how quickly the industry responded to change and how quickly it was adopted. There was a fairly long lead time before. I don't think you'll have that opportunity anymore to achieve that. What are your thoughts on that?
No, I agree. I think that the one variable that we're going to have that's going to get smaller and smaller and smaller is time.
Right.
I think that the time to market is going to get compressed. The time for tooling, so if you're going to go to market and you got to create tooling, right now, that's a real challenge. Can you get your tooling done in 6 weeks? Oh, okay, that's not fast enough. You need to get it done in 4 weeks, and then it's going to be 2 weeks. And so we need to be focused on technologies. I think that's what this whole smart manufacturing is looking at, is we need to be looking at what technologies can help industry get to market faster. Because first to market is usually best to market. Or you're going to be able to, if you can get to market fast, you can adapt fast, and I think that's going to be key to be competitive in the next 20, 30 years.
Right.
Now, I think what works in our favor is actually what we worry the most about, which is the workforce. A lot of these kids that are coming up and getting into the workforce are different. And to me, it's really exciting. They're tech savvy. A lot of these kids have never lived without an iPhone. The digital is their normal form of communication, which is where manufacturing is going to go. So I think that the workforce that's coming up, they're going to have the innate skills that we really need. The challenge that we have is convincing them. And it's really not even convincing them. It's really convincing their parents that manufacturing is not what it used to be. It's a high-skilled market, and it's an exciting market, and it's an exciting career. And so to me, that's one of our fundamental, for SME, our fundamental roles, and I think we're doing a really good job of it, is communicating to parents and communicating to kids that the manufacturing of tomorrow is extremely exciting. It's an unbelievable career, and it's vast in terms of opportunity. we have right now. We're right in the middle of the summer. We've got tons of kids here, interns working with us. We usually hire about 100 students in the MDF, and they're doing all kinds of stuff. And one of the things that has me most excited was I had this young lady. She's from the University of Florida, an undergraduate, and we just gave her some of these augmented reality glasses and said, figure out what you can do with it. And it's unbelievable. You get this kid these new tools, and she's got it. We're working with Cincinnati Incorporated, and she's got these goggles where you walk up and you look at a QR code on the machine, and all of a sudden it downloads all the data associated with a part that we're printing. And you can walk around and look inside the machine and see data like you can look at thermal imaging data, you can look at CAD data, you can look at all kinds of data. And these kids are picking up this technology much faster than I ever could imagine, starting to think of creative ways to use it. And so I'm really bullish on the workforce. It's just what we have to do is make sure that we can convince these kids that this is the career of the future. This is where you have tremendous opportunity.
Right. I know it may sound kind of, I think people sometimes have gotten this bad image of millennials and the next generations behind them. But I think if you go to any one of like the robotics competitions, or you go to any of these 3D printing competitions, it will change your mind when you see what these kids can do. It is phenomenal.
I couldn't agree more. I remember my wife was a high school English teacher, and this was back around 2010, and she was working at a new school, and I didn't know anything about the first robotics competition, and they were brand new school, and they decided they wanted to try to do this. She said, Lonnie, I think you know a little bit about robotics. You should go volunteer as a mentor. And I was like, that sounds like a lot of fun. It might be, one night a week, 2 nights a week. And I remember going and just being blown away, number one, by what was expected. You got 6 weeks to design and build a fairly large robot. They're like 120 pounds. They're very complex. And I remember about 3 to 4 weeks into the competition, her calling me up going, you need to come home. I was like, you don't understand. We're way behind schedule. These kids, we don't, you're trying to teach kids how to use wrenches, right? And so I was, at the end of the season, the first season, I was done. I was like, I'm fed up. I'm tired. This is another full-time job. But I went to the competition, and to see, hundreds or thousands of kids excited about making stuff, just blew me away. And I fell in love with it. I've done it for 10 years, 8 years. It's absolutely inspirational. First is I can't remember, for the inspiration and recognition of science and technology, but really in it, what they talk about is trying to inspire kids. But when you get involved in this, you come away just as inspired as the kids in terms of what their capabilities are. I think I am very bullish on the millennials and what their capabilities are. They just need to give them a little bit of direction, and then they can absolutely run with it. And there's hundreds of thousands of these kids in the United States right now.
Yeah, it's been something that really, when I got involved in some of the competitions that they have, VAX and First Robotics, and even the Lego competitions for robotics, it's I didn't realize just, I guess if you just give some of these kids a little direction and help them along with a few things, they can, they're so adapted to the new technology that they pick up a phone and they know how to work it faster than you ever could.
To me, it's like in sports. In sports, college will go and recruit at the high school level, and we should be doing that.
Right.
and we should be going not to the colleges, but to the high school level and looking for these kids and mentoring them and encouraging them with the intent of them coming working for us. I'm doing it all the time,
Right.
all the time. And I think it takes a little bit more effort, but it reduces a lot of risk in terms of hiring. For most companies, when you're hiring a staff, if you're going just by a 5-minute or 10-minute interview and a sheet of paper, that's crazy.
Yeah.
Get in and get around these kids and look for the talent that you really need. It's out there. It just takes a little bit of effort and a little bit of mentoring, and it will ensure your competitiveness in terms of workforce.
Right. Yeah. No, I couldn't agree with you more. Speaking of technologies out there, what are some of the challenges that you see that we're faced with in material science and in the advancement, how we're going to get to that next level in 5 years? What are some of the things that you see as bottlenecks for us?
Yeah, that's a great question. I think ironically, some of it is in the software and in the controls. When you start looking at composites, because there's carbon fiber, the cost of carbon fiber is going to be plummeting. So you can make lighter, stronger, stiffer components. But how do you teach somebody how do you get the design tools to be able to design and predict the performance of these parts with these new materials? That's challenging. Also, the area I'm most knowledgeable about is an additive, and an additive, having the phrase that I hear that makes me kind of cringe a little bit is complexity is free. No, it's very expensive. Because the design tools takes a lot of effort to be able to design something that can be 3D printed, and each technology, all of the additive technologies are different, and so creating those tools for the designer to be able to rapidly design and successfully manufacture products is critical. I think that where manufacturing's going with better and better machining centers, better and better additive systems, they're getting a lot more intelligent in terms of their controls and the reliability. But it's always that first step, the design, that is most critical. It's kind of like the foundation of your product is that design. And I think coming up with design tools that embed that knowledge of that machine, what you're going to be making it with, is really critical. And also one of the things that really is to me challenging is finding good designers. Usually in physics, people have their greatest breakthroughs when they're young because they're unencumbered by reality. They can come up with great new scientific discoveries. They're not ingrained in how things are done. Engineering is almost the opposite, is that it takes time to learn what you can and cannot do. And we need to accelerate that. So I think there needs to be new tools that are developed that enable designers to accelerate their learning curve and minimize the mistakes so that they can get the product faster.
Right.
And again, I think if I had somebody asked me what's the one theme for the next 5-10 years that we need to be focused on at speed, we have to be going faster. You have to get the products faster because it's a competitive world, and time to market's critical.
Yeah. And you've seen some of the changes that there have been even in the consumer electronics and how sensors and some of the smart manufacturing has been incorporated into their products in the consumer side. I think we need to extend that into the workforce from a manufacturing standpoint, because we're a little bit slower to respond, but the demand from the consumers is there.
Yeah, absolutely. One of the things that amazes me is from the electronics side is the new industries that are enabled, not the new products, the new industries that are enabled by these innovations. And if you look, the largest cab company doesn't own a car, Uber.
Yeah.
And it's all electronic. You sit here and I can be on my phone and I can say I need a car and I can watch this car come to me. And I think one of the largest hotel chains, Airbnb, doesn't own a house, and so these are different business models. And
Right.
and I think when we start looking at all the smart manufacturing, the ability to see what is available, what capacity is available, what capabilities are available, and nationally, locally, whatever you want, what the supply chains look like. Again, if you look at all of these things, the elements that we need for manufacturing, and if you say I can get information instantaneously, and then I can direct that material instantaneously to where it needs to go, the optimal place that it should go. It's going to, that's again looking at this grand optimization scheme for manufacturing. It enables us to be much more adept and nimble in terms of responding to demand. And again, going back to that theme of speed and speed to market, I think these tools that are being developed in other industries, manufacturing should really be looking at them, thinking about how we can use that to transform our industry.
Yeah. And it's been slow, I think, in a lot of areas. I know when we talked and when we had actually walked around some of the smart manufacturing show that there was just up in Boston, what was interesting is that all of these manufacturers of different types of products, whether it's machining centers, whether it's lasers, whether it's 3D printers, whether it was fabrication equipment, all of them are now having sensors that can talk real time to your phones, to your computer, and give you real time feedback on what's actually happening. And I think
that's key. And having that knowledge and how you use it is, to me, what one of the keys that we really need to unlock. It can really transform. I was talking to Tom Purpose, and he was telling me an interesting story. He had a student that put a little accelerometer on a bandsaw, and it had a little wireless sensor. It was all wireless, and slapped it on it. And basically the saw said, only for wood, but it would measure the vibration and determine if somebody was using metal on it. And I think he had a Nest camera hooked up to it, so if somebody was using the wrong material, they could take a video and say, "Look, can you read?" But you see where you could go with this is from a safety perspective. You could measure it. There's knowledge there, and you can shut down the machine before somebody gets hurt or the machine is damaged. You can log that information and look at how, say, the cutting forces are changing and schedule maintenance such that you're not schedule maintenance in an intelligent way rather than just random arbitrary through time. Look at it through performance. There's all kinds of things we can do. It's just, to me, it's just getting the right people being creative and thinking about it, and kind of going back to those millennials. These millennials kind of get it. They really understand. They're unafraid about using data and using sensors, using your phone, and so embrace them. Encourage them to try new things with your technology.
Yep. One thing I think that the millennials are fairly low in tolerance of, though, is bad processes, bad technology.
Yep.
If they get in there and they see that your technology isn't very good, they are not afraid to tell you that.
Nope. Well, and I think another thing, so there's a couple of things that I'm very bullish on them, but there's challenges. And also there's two other challenges I see with the younger generation. And we just need to understand it and respect it and figure out how to work around it. Number one is they are very social, and they love showing what you're doing. Mm-hmm. And if you're working in an area that you have a lot of intellectual property, you got to figure out how to keep them happy. I mean, it's great that they want to brag about what you're doing, and that's fantastic. But we need to be able to harness it in a way that it still protects your intellectual property.
Right.
And the second thing is that they're very mobile. A lot of the millennials that I've talked to stay with a company for 5 years is kind of alien to them.
Right.
Well, in manufacturing, if you're in computer programming, it's fine. You can transition from one company to another company to another company. But when you're in manufacturing, there's skills that it takes you years to get the skills that you need to be really effective. And so, like most of the engineers I hire, I look at the first 2 years of training. After 2 years, they start to make money for me, and so if they're moving on after 2 years, well, that's hard. That's really painful. So how do you create an environment and a technology, but most importantly, an environment where they love to come to work, and they'll work crazy hours. So how do you create an environment where they come in and be very productive and want to stay for 20 years, 30 years? I think you can. Yeah. But we need to be understanding that we're now dealing with a different generation than previous generations, where somebody would come in and stay with the company for 20, 30 years, 10 years. How do we take this new workforce and create an environment that is they just love? And I think you can.
Yeah.
But we just have to be proactive about it.
Right. Well, sir, I think we're just about out of time. I want to thank Dr. Lonnie Love from Oak Ridge National Labs for being with us today on the Destiny of Manufacturing podcast. I'd like to thank our sponsor, the Precision Metal Forming Association and the PMA's Educational Foundation, for sponsoring our show. So go out there and have a great day, everybody. Thanks.